Good morning, students. Welcome to video lecture on electromagnetic waves and transmission lines. Subject code U18EC403. Topic: tricks to remember equations in coordinate systems. Divergence and curl in Cartesian coordinate system. In Cartesian coordinate system, you just remember the notation 1, 1, 1. Let us write the curl first. Del cross A is equal to AX, AY, AZ, dou by dou X, dou by dou Y, dou by dou Z. Vector components AX, AY, and AZ. The vector components in Cartesian coordinate system are AX, AY, and AZ. Now here what you have to remember is the notation 1, 1, 1, 1, 1, 1, 1 divided by the notation product. It is the notation product in Cartesian coordinate system. You can apply the same concept for the other coordinate systems. Del dot A. Del dot A is a scalar quantity dou by dou X of plus dou by dou Y of plus dou by dou Z of close the bracket. Remember the notation 1, 1, 1. One by the product of 1, 1, 1 is 1. So the LCM component is 1 and it is AX. Here it is AY and AZ. Its LCM component is 1. Its LCM component is also 1. And once again divided by the product 1 into 1 into 1. In this fashion, we can remember the divergence and curl in Cartesian coordinate system. Let us apply the same concept in cylindrical coordinate system. In cylindrical coordinate system, you have to remember the notation 1 rho 1. In cylindrical coordinate system, the coordinates are rho, phi, and z. So del cross A is a vector quantity. Once again, apply the same concept here. A rho, A phi, A z, dou by dou x, dou by dou rho, dou by dou pi, dou by dou z. The vector component is A rho, A phi, and A z. 1 by. Now here we have to apply the notation 1 rho 1, 1 rho 1, 1 rho 1. In denominator, you substitute the product of 1 into rho into 1. In this fashion, you will get the curl of cylindrical coordinate system. Let us move to the divergence. del dot A is equal to dou by dou rho of plus dou by dou phi of plus dou by dou z of, close with the brackets A rho, A phi, A z. Now here the notation is 1 rho 1. Now here the LCM component 1 into 1, rho into 1 is rho, so the LCM component is rho. Here 1, its LCM component is rho 1 by rho. Likewise, you can write the divergence and curl in cylindrical coordinate system. Once again, you can apply the same principle in spherical coordinate system to remember the divergence and curl. In most of the cases, you will be shown in many textbooks the simplified equations. It is not possible to remember those equations. But if you follow the trick, you can remember the divergence and curl in either it is Cartesian, cylindrical, or spherical coordinate systems. In spherical coordinate system, a point is represented by r, theta, and phi. And here in spherical coordinate system, you have to follow the notation 1 r sine theta. In Cartesian, it is 1 1 1. In cylindrical, it is 1 rho 1. Now in spherical, it is 1 r sine theta. Now del cross A is a vector quantity. Once again, follow the same notation. AR, A theta, A pi, dou by dou r, dou by dou theta, dou by dou phi. Vector components AR, A theta, and A phi. 1 by. Now you apply the notation, that is 1 r sine theta, 1 r sine theta, 1 r sine theta, r a phi r sine theta, r a theta, r sine theta, a phi. Now here you have to apply the product r square sine theta in the denominator. The notation product is 1 into r sine theta, that is r square sine theta. And let us write the equation for curl, equation for divergence. Del dot A is a scalar quantity. Once again, follow the notation dou by dou r of plus dou by dou theta of plus dou by dou phi of, close the bracket. Here AR, A theta, and A phi. Now remember the notation 1 r sine theta. Now the product is r square sine theta and its LCM component is r square sine theta. For 1 it is r square sine theta, for r it is r sine theta, and for r sine theta it is r. And once again you can write the product component in the denominator, that is 1 by r square sine theta. In many textbooks you will get the simplified equation of the divergence, but it is not possible to remember that equation. you can follow this trick to remember. Once again, note down the curl of a vector in cylindrical, Cartesian cylindrical and spherical coordinate systems. 1 1 1 1 1 1 1 row 1 1 row 1 1 r sin theta 1 r sin theta 1 by r square sin theta, here 1 by rho. And the simplified equations are given below. Refer to those equations. Gradient of a scalar. For that, note down del in Cartesian dou by dou x ax plus dou by dou y ay dou by dou z az. Here the notation is 1 1 1. So 1 1 1. In cylindrical coordinate system, it is dou by dou rho a rho cap plus dou by dou phi of a phi cap plus dou by dou z of a z cap. Here the notation is 1 rho 1 1 rho 1. And in spherical, it is equal to dou by dou r of ar dou by dou theta of a theta plus dou by dou z of dou by dou phi of a phi cap. In Cartesian, you can follow the notation 1 1 1. The notation is 1 1 1. In cylindrical, the notation is 1 rho 1, that is 1 in denominator rho d phi, here in denominator dz. In spherical, it is 1 r sin theta. So you can follow the notation 1 r in denominator r sin theta. And let v is a scalar, then del v is equal to, you can simply substitute v in Cartesian cylindrical and spherical coordinates. You will get the equation for gradient of a scalar. You can refer to the equations 1 1 1 1 rho 1 1 r sin theta. Vector transformation between Cartesian and cylindrical coordinate systems. As we know, x equal to rho cos pi, y is equal to rho sin pi, z equal to z. The coordinate relation between Cartesian and cylindrical coordinate systems. Now let us move to the notation AX, AY, AZ, A row, A5 and AZ. X row relation is cos pi, Y row relation is sin pi, and row Z relation is 0. Z with XYZ is 0, 0, 1. XZ no relation, YZ no relation, ZZ it is equal to 1. And to get the middle components, partial differentiation of dou by dou phi. Here it is phi. You have to perform the partial differentiation of the first column to get the second column. That is, the second column elements are minus sin phi. Sin is cos phi. 0 equal to 0. Now you can write the equations for A row components. For A row components, you can take the product of sum of products of AX cos pi, AY sin pi 0. That is AX cos pi plus AY sin pi. AZ into 0 is 0. And A phi is equal to AX minus sin pi minus AX sin pi plus AY cos pi, and AZ is equal to AZ, and in another notation the AX components are AX is equal to, now this time you can take the products in this manner, that is A row cos phi minus A phi sin pi, and AY is equal to A row sin pi, A row sin pi plus A pi cos pi, A pi cos pi, and AZ is equal to AZ. Now here, with the help of knowing the relation between the coordinates of Cartesian and cylindrical, you can transform the vectors from Cartesian to cylindrical or from cylindrical to Cartesian. Let us apply the same concept to transform the vectors between Cartesian and spherical coordinate systems. The relation is x equal to r sin theta cos pi, y is equal to r sin theta sin pi, z equal to r cos theta. Now follow this trick. Ax, Ay, Az, Ar, A theta and A phi. Now xr relation is sin theta cos pi, yr relation is sin theta sin pi, z is cos theta, and ax ay is that relation with a pi is already derived, minus sin pi cos pi 0. You can write minus sin pi cos pi 0. Now to determine the second column elements, you can partially differentiate these elements with respect to theta. That is, you will get by partially differentiating this, you will get cos theta, cos pi, cos theta, sin pi, and minus sin theta. Now once again you can follow the same notation uh, to write the equation for AR. AR equation is, you can take the product in this fashion, that is AX sin theta cos phi plus AY sin theta sin phi, and plus AZ cos theta, and for A theta you can take the products of AX and these terms, sum of the products of these terms, that is AX cos theta cos pi plus AY cos theta sin pi minus AZ sin theta. Likewise, you can write uh, the value of A pi also. For A pi, you can follow AX minus sin pi, AY cos pi, AZ 0. Follow the same procedure to write the components of vectors in spherical coordinate system, and for AX the vector components in Cartesian coordinate system. For AX it is, now here this time you can consider this direction, that is AR sin theta cos pi plus A theta cos theta cos pi minus A phi sin phi. Likewise, you can write the equations for AY and AZ. Thank you. We will meet with the